Howdy, good afternoon. Hi, period four. You're getting a personalized video from yours truly. Um, I am out here at the end of the day, so you're getting this personalized video. Let's jump into it. You hopefully saw my announcement and you're on Canvas already. And if not, maybe I talk slowly here for a second to give you some time to log in. But we're in 4.3 and we are dividing. Last class period, we added, subtracted, and multiplied polynomials. Today's one and only focus is to divide polynomials. So before we dive into before we dive into dividing polynomials, let's just think of a good old standard division problem, right? Good old fashioned long division. If I did 310 divided by, 15, right? Or, let's make it a longer number. How about 3,145 divided by 15? Let's do 65. Sorry. 3,165 divided by 15. What do? We look here and we say, how many times does 15 fit into 3? Or 15 times what equals 3? The thing is nothing. Okay, so we move on to the next term, the 31. We look at this as 31. How many times does 15 fit into 31? Or in other words, 15 times what gets us close to 31? And the answer is 2, because 2 times 15 is 30. And then what do when we're long dividing? Now that we've done the 2 times the 15, we subtract. So 31 minus 30 is 1, and then we bring down the next number. And then we ask ourselves the same thing. 15 times what gets us 16, or at least close to 16, and that would be a 1. And then you multiply. 1 times 15 is 15. And you subtract. Sorry, I'm running out of room. But you get 1 and you bring down the 15. And how many times does 15 fit into 15? Once. So, and then to end it off, right? Why is that a nice clean 150 or 211? Because when we do the final 1 times 15 and get 15 and we subtract, we get a remainder of 0. You remember good old fashioned long division? Well, we can long divide polynomials in a similar fashion. So I'm just going to leave that there and attempt to divide letter C here. So let's set up our division like a normal long division problem. And the question that I was asking there each time was, what does 15 times what gets me close to 31? And that's 15 times 2. So x times what gets me x cubed? And the answer, x squared. X squared times x gets me x cubed. So what came next as I was doing my division? Actually, let's go ahead and drag this down here. What came next was we multiplied, correct? We did the 2 times 15 to generate a 30. So x squared times the x plus 1. So watch how this happens. We're going to get x cubed plus x squared, because x squared times x is x cubed, and x squared times 1 is 1x squared. If you'd like to put a 1 there, you may. What came next was subtracting. So let's subtract, and x cubed minus x cubed goes to 0, and 2x squared minus 1x squared is 1x squared. And after we did that, we brought down the next term. So we bring down the next term. And we ask ourselves the same question once again. What did I ask? We had this 16, and I said 15 times what gets me 16? And the answer was 1. So I asked the same thing. X times what gets me x squared? And the answer is x. And I did 1 times 15 to get 15. Well, now I do x times x plus 1. So x times x is x squared, and x times 1 is 1x. So when I come in here and subtract, x squared minus x squared goes to 0 again. Negative x minus 1x is negative 2x. And we bring down the negative 2. We're at the final hurrah here. One more time. X times what gets me negative 2x? That's x times negative 2. Negative 2 times x gets me negative 2x. And negative 2 times 1 gets me negative 2. So this final bit of subtraction leads to 0, a remainder of 0. Negative 2x minus a negative, that means addition. So negative 2 plus 2 is 0. And the same thing occurs. Negative 2 minus the negative 2, that means plus 2. So negative 2 plus 2 is 0. We get a nice remainder of 0. I'll maybe pause. You're looking at this on the screen. I'll pause and you can kind of finish that up if I got a little ahead of you. But hopefully the long division process is coming back to you a little bit. I know we don't do that really on a daily basis, especially, with calculators and all, but calculator's not going to do polynomial division here. All right, so if you look at the assignment 4.3, I have it set up the same way where I'm doing a couple problems and then I want you to try a problem in the assignment. And maybe we could get the video paused here in just a second, but not quite yet, because let's look at my final result here. This was my final answer, right? But I want to highlight the steps. We got this, which led to this. Then we got this, which led to this. Then we got the same thing and got a remainder of 0. So why am I bringing this up? I know this is a bit convoluted to express via video, and if I was in person, maybe it would be a little bit better. But if you look at the assignment, take a look. Use polynomial long division. This is problem C on page 87 of the student journal, the one we just did. Order the expression below in order of your division steps. So here's the original problem. X cubed plus 2x squared minus x minus 2. And if you look at my steps over here on the left side of the screen, what came first? The x cubed plus x squared. Boom. Then what happened? After we did the subtraction, we got this, which is why I'm going to do x squared minus x as my next one. And then that led us to the x squared plus x. Boom. Which then led us to the negative 2x minus 2. Notice I have two negative 2x minus 2's. Use this one first. That literally says the word first. And use this one second, which led to what? A 0. And the final answer, after we did the division, was what I highlighted in red here, x squared plus x minus 2. So obviously that goes at the final end, the final answer one. I know that's a little strange, maybe, right? That's not exactly the most natural thing, but I'm trying my best to allow you to show me what you're doing through Canvas, right? I want you to submit work. I want you to do the long division, and this was what I came up with to allow you to demonstrate the steps. You know what I'm saying? So, and honestly, it helps you check your answer because at least you're not just coming up from scratch. You have these blanks to help guide you through it. So I hope that you can appreciate that. Let's do one more together, and then I'd like you to try number 2. Okay? So let's do one more together. and then you can try number 2. So let's do F, shall we? So there's my setup. I'll give you a moment. So how does division work? We're asking ourselves, x times what gives me x cubed? The answer, x squared. X times x squared gets me x cubed. What do we do with this? Multiply it to this expression here. So x squared times x is x cubed, and x squared times negative 3 is negative 3x squared. What happens next? We subtract. That becomes 0. And when you subtract a negative, that's the same thing as adding. So negative 2 plus 3 is a positive 1x squared. Bring down the next term. We ask ourselves the same question again. What multiplies to x squared? Or what can you multiply x by to get x squared? The answer, simply x. X times x is x squared. So we take this x and multiply it to the whole expression here, and you get x squared minus 3x. And you perform subtraction once again. This becomes 0, of course. And again, when you subtract a negative, that's addition. So negative 5 plus 3 is negative 2x. And you bring down that final term. Ask yourself one more time, x times what gets me negative 2x? The answer, negative 2. Negative 2 times x is negative 2x, and negative 2 times negative 3 is positive 6. When I subtract, I end up getting 0, a remainder of 0. So these would be my steps, right? The original problem, and then piece by piece by piece as I solve the problem. Okay, let's all. I know it feels. I said, oh, maybe we could pause it, and then I like did a whole other example. But maybe now we could get a pause for me, if possible, and let's try question number 2 on the assignment. Right, looking at this one right here. Use polynomial long division. So try that one out on your own. You've got some space in your notes. Give that a chance. And I'm going to pause my recording. Okay, so I don't know if the video got paused or if there was a quick cut, but here's the problem that hopefully you all just attempted if the video got paused. And yeah, there it is. I mean, maybe you were able to help one another, right? And work through that problem. But we've got x squared times x gets us that x cubed, and x squared times 3 gets us 3x squared, and we subtracted. When I subtracted the 3, I got the negative 5, and we brought down the negative 9. X times negative 5x gets us negative 5x squared. So when I do that multiply, negative 5x times the 3 gets us the negative 15, and when you subtract, you're adding, so that becomes a positive 6. Bring down the 18. And when you do the 6 times the 6x, boom, and 6 times the 3, oh, it's also 18, and that's why it subtracts to 0. So if you pull that open, the order is, sorry, a little clunky here, but I'm doing my best. The order would be, okay, here's the original problem. We did x cubed plus 3x squared. That was the first thing. When we did the subtraction, we were left with the negative 5x squared minus 9x. and then that, and then the first 6x plus 18, the second 6x plus 18 left us with a remainder of 0, and we had that final answer there. So hopefully that's legible for all of us there. I can maybe zoom in a teensy bit. They're going, no, that should be fine. Okay, so there it is. Let's contemplate here for a moment while I got this up and I got this problem. What is the significance of the fact that we get a remainder of 0? Maybe you can ponder that for a moment. What, like, what are we discovering, if you will, right? If you get a remainder of 0, like think about just regular numbers, when we say that 50 is divisible by 5 and we get 10, what are we saying there, right? It's a word that starts with the letter F. It's a factor. It's a factor. If Right? I mean, what are the factors of 50? 1, 2, 5, 10, 25, right? There's all these divisors. But, we use that word like greatest common factor, and we have been doing that, right? When they're all divisible by a certain number. When those numbers are divisible by a certain number, we're calling it a GCF factor. So what are we discovering by doing this polynomial long division? We have just discovered that x plus 3 is a factor of this long polynomial expression. We've been factoring simple things, that look like this or whatever, right? X squared plus 6x plus 9, that factors into x plus 3 and x plus 3, right? But now what about longer expressions that look like this and that it's x cubed? We're discovering a factor here by getting a divisor, by getting a remainder of 0. We have just successfully determined that x plus 3 is a factor. Interesting. Okay, so let's move along here and let's do what are we at time wise? 17 minutes here. So let's look at number 2 really quickly here on the next page. I'm going to go a little bit quicker just simply because I think I can. I think I have the right to do so a little bit. I mean, we've done a couple of them now. So what's different here is the fact that, okay, yeah, they look shorter, but they're not just shorter and that means the problem is easier. You need to have placeholders for your missing terms. You need to have placeholders for your missing terms. So x cubed minus 4x squared plus 0x plus 0. Okay? I have all those placeholders of the 0x and 0. And when I come in here and do division, I have x squared minus 0 or plus 0x, whatever you want to say, minus 16. Because we're missing an x term, and here we're mixing an x and a constant. And now I do the same division. It's just that there's those zeros floating around. So what do I mean same division? Well, how does this work out? X squared times what is x cubed? Simply x. And then you do the multiplication. X times x squared is x cubed. X times 0x is 0x squared. And x times negative 16 is negative 16x. And you subtract. Negative 4, well, this becomes 0. And negative 4 minus nothing is still a negative 4x squared. And 0 minus negative 16 is plus 16x. And you bring down the 0. Not that that really does anything, but you bring down the 0. So now x squared times what gives me negative 4x squared? Negative 4. And negative 4 times x squared is negative 4x squared. Negative 4 times 0x is still 0x. And negative 4 times the negative 16 is a positive 64. And when you subtract, you're left with, that goes to 0. 16x plus 64. This is our first instance of ending the problem without a remainder of 0. Okay? So that's perfectly okay. That's perfectly okay to end in that situation. All right. So we just say that this is our remainder. We just say that that's the remainder. And if you take a look at the problem that I created, I won't switch screens because I don't think it's necessary. But you'll see that the final answer, if everyone can maybe look at number 3, right? It says final answer 2x squared plus 3 with remainder of 16. So I don't I'm not asking you to do too much with the remainder. There are some things that we can do with the remainder, and I'm sure we'll look at that. But right now, I just want you to get to the end and appropriately place your placeholders. So, can we all look at maybe another pause for me, please? Maybe another pause for me. Let's all look at number 3 and the assignment and try to correctly polynomial divide one more time. So let's try that out, and I'm going to pause on my end. All right, and I'm back. So if you look at that original problem on number 3, it's missing an x cubed term and it's missing the x term. So I put zeros as a placeholder. And then the thing that's doing the dividing, the divisor, is 2x squared minus 5. So it's missing the x term. So I put a placeholder in for that. And this goes by pretty quickly because of how long the expression is. So I looked at the 4x to the fourth and I said 2x squared times what? Times 2x squared. 2 times 2 gives you the 4, and x squared times x squared. And when you multiply that to each of these, that is still going to be a 0, and that becomes negative 10x squared. And you subtract 0, 0. When you subtract the negative 6, that's a positive, or sorry, when you subtract the negative 10, that means you're adding 10, and negative 4 plus 10 is 6. Bring down, and you'll notice I brought down 2 terms because this 15 needs to line up with something, right? If you didn't bring down both terms, which is maybe a mistake you could have made, you might have been like, this feels a little off, right? If you didn't have something for the 15 to line up with, what would you do? You know what I'm saying? So you got to bring them both down so that way when you multiply by 3, because 3 times 2 gives you the 6x squared, when you do that, when you do the 3 times 0, that lines up nicely. And when you do the 3 times the negative 5, that lines up nicely with the 1. Do the subtraction, you get 0, 0. Subtracting the negative 15 gives you a plus 15, and that's where the 16 came from. So if I switch one more time here to display the answer for you, I would arrange it as, okay, here is the original problem with all my 0 placeholders. The first thing that I brought down was the minus 10x squared. That left us with the 6x squared and the 1. Then we subtracted this. That left us with the remainder of 16. And boom, that's my final answer. The 2x squared plus 3 with a remainder of 16 is your final answer. All right, let's switch gears slightly. Let's switch gears slightly. We're still dividing. We're still dividing, but we're going to do a different type of division, and that's synthetic division. So synthetic division makes a problem like number 8 go by a lot quicker. Okay? I'm going to pause for just a half second. All right, and back. So it makes a problem like number 8 go by a lot quicker. Instead of doing that long, literally long division, we can set something up doing the following. So set this up with me. Look at the coefficients. Let's write them in a horizontal line like so. Leave a little bit of space and then draw a horizontal line like so. And then off to the side in the box, in a box off to the side, take a look at this. You see a -4, correct? Let's put a +4 in the box. And here's the process of synthetic division. So this is like a little shortcut. Instead of doing polynomial long division every single time, this is our shortcut, synthetic division. The first step, bring down the very first coefficient, 2 in this case. Then take that number and multiply it by the number in the box. 2 times 4, 8. And then add down. This -11 added with the 8 is -3. And then multiply this number by the number in the box, and you get -12. And then add down. 11 plus the -12, that means -12, is -1. Take that -1 and multiply it by the number in the box. -1 times 4 is -4. And add down. You're adding the 4 with the -4 and thus getting 0. You take that 0 and multiply it by the number in the box. 0 times 4 is 0. And you add down. 4 plus 0 is 4. So, what just happened? We just found our final answer of 2x cubed. It lowers by a degree. When I take this expression and divide it by x, it lowers it by a degree, and everything is descending from there. And I want to introduce one other way that remainders can be written. Instead of simply writing remainder 4, what is also true is the remainder over the divisor. So we got all of these nice, pretty whole numbers. But what we're saying is that, wait a minute, there's this leftover piece, and that's our remainder. Okay? So in short, what just happened? Add down, multiply diagonally is what I like to say. We add down and then multiply diagonally. Add down and multiply diagonally. Add down and multiply diagonally. What are we multiplying by? The number in the box. So if we look at the assignment with me, I have set up this problem where you can type the numbers in the blanks. So my table is my attempt at simulating your synthetic division. The number that went in the box, 4. Why can't I? Oh, it's just not. It's behaving strangely then I. Okay. So the number that goes in the box, 4. And then in each of these, we had the 2, the -11. If you just hit tab, everyone, if you just hit tab, it switches you to the next blank. So -11, and then 11, tab, 4, tab, 4. We know that this is going to be blank right here, right? You know, see how I dropped that 2 straight down? And then we had 8, -12, -4, and 0. I'm just hitting tab, everyone. I'm just hitting tab to quickly skip through those blanks. And then 2, -3, -1, 0, and 4. So when you do the synthetic division, again, what was our final answer? Let me blow it up nice and big here. 2x cubed minus 3x squared minus 1x. We can erase the plus 0 because it doesn't really matter. Plus the remainder of 4 over x minus 4. Why was it x cubed? Because it's always 1 degree lower. Did you notice that in the previous problems? Maybe you did, maybe you didn't, right? Well, that's not a good example because we divided by x squared. But this example, when we took the um, x cubed and divided by an x, it resulted in an x squared. We took this x cubed divided by an x, and it resulted in an x squared. It always lowers by 1 degree when you divide by the x. So, what is my correct choice here? Looks like option B. A is really tempting, but that's not a remainder. That's just plus 4, right? It was a plus 0, and we had a remainder of 4. So B is the correct expression. Let me do one more. And then from here on out, I just want you to, I'll do one more synthetic division, and then you'll try this one, and then the rest of the assignment is yours. So let me do one more synthetic division with you. Let's look at number 7. What do you think we're going to have to look out for in number 7? Missing terms. We've got a 2x cubed, a 0x squared, a 0x, and a minus 54. I just remembered one other problem that we have to do. I'm sorry, I'm a loser. I might be able to do a shortcut for you. And why does negative 3 go in the box? The opposite of the number in the factor. That's a plus 3, so the negative 3 goes in the box. What do? Say it with me if you can. Add down. 2 plus nothing is 2. And multiply diagonally. What are we multiplying by? The number in the box. 2 times negative 3, negative 6. You add down 0 plus negative 6 is negative 6. And multiply diagonally by the number in the box and get positive 18. You add down 0 plus 18 is 18. And then you multiply it diagonally by the number in the box, and you get a negative 54 here. And then you add down, and it's tempting. You might be thinking, oh, that's going to make 0. No, because when you add the two negatives, it's still negative. So negative 108. So our final expression, it lowers by a degree. So 2x squared minus 6x plus 18 with a remainder of 108 over x plus 3. I hope you like synthetic division. It is speeding up the process of polynomial long division by a landslide. It is speeding us way up. There is a time and place for polynomial division, but synthetic division makes life a lot easier. Okay, so can I get one more pause? Pause for dramatic effect and try the next synthetic division problem, and we'll cap off. I'll say some final words there. All right, so one more pause. All right, let me run through it super quickly here. Adding and multiplying. What have I said in class before? We ain't got time to worry about multiplying, adding, division, and subtraction, right? And if you can, if you got a calculator by your side, maybe the numbers get too big, clicky, clicky, clacky, but this should be pretty quick. This should be life-changing for you. This is quick division. 3 plus nothing is 3. Multiply by the number in the box. 3 times negative 5, negative 15. And add down. 0 plus negative 15 is negative 15. Multiply by the number in the box. Positive 75. And add down. Negative 80 plus 75, negative 5. Multiply by the number in the box. Positive 25. And add down. 25 minus the 21 is 4. Multiply by the number in the box. Negative 20. And add down. Negative 13. Boom. Just like that. And so there you can watch this video back. You don't need to, nobody needs to pull out their phone and take a picture of the screen. I have this posted on Canvas. So if you want your answers, here they are. You can go back and watch the video. But there it is. You can fill in the blanks of the table, right? You can fill in the blanks of the table using these numbers. Add down, multiply by the number of the box. Add down, multiply by the number in the box. So this was x to the fourth. So now your final answer is 3x cubed minus 15x squared minus 5x plus 4 minus 13 over x plus 5. Which, as far as those options are concerned, that's option B again. When looking at number 5. Y'all just tried number 5. All right. One side comment here. There's one other benefit of synthetic division. There's one other benefit of synthetic division. So when I said that was the last thing, I lied. I'm sorry. I thought I remembered there was one other thing. But luckily, it doesn't change what you're doing. Luckily, it doesn't change what you're doing. But if you flip a couple of pages, one or two pages, however many it is, one page, to use synthetic division to evaluate the function. We have evaluated functions in this class countless times. We've had a question like this on so many occasions. F of 2. To evaluate a function means to take whatever the x value is and plug it in for x. We have done this numerous times already. You remember doing this? And some of us, I'm not going to lie, are not 100% on the up and up with your order of operations. And that's okay. I'm not hating. But here's another way to evaluate the function. Instead of sitting here and breaking out your calculator and doing 2 cubed, which is 8, times negative 3, 2 squared, which is 4, and then, whoops, not 14. And then negative 17 times 2, which is negative 34. And then coming through here again and doing negative 24. I'm going to do it all the way out, right? Look at this work that I'm having to do. Negative 20, if you're not frantically writing this down, that's okay. Negative 24 plus 16 is negative 8. Minus 34, minus 6. You end up with negative 42, minus 6, which is finally negative 48. Now, the quicker you are in your head, the quicker you get there. But I had to plug in for x and follow the order of operations. Or, I hope I didn't mess that up. That'd be embarrassing because I'm just rushing through it. Or, what does the question say? Use synthetic division. So, check this out. If I set up synthetic division, negative 3, 4, negative 17, negative 6, and this isn't a factor. It's just the number 2. There's a distinction. There's a distinction. There's a distinction. I'm not dividing by a factor. They're just handing me a number. I'm going to put literally that number in the box, and I'm going to perform synthetic division. But I'm not actually dividing. I don't actually care about the dividing part. I'll tell you what I care about in just a second. Add down, multiply diagonally. Add down, multiply diagonally. Add down, multiply diagonally. And the final number is the answer. Whoa! So when you do synthetic division, add it down, multiply by the number in the box. Add it down, multiply by the number in the box. Add it down, multiply by the number in the box. Do you see how quickly I did that? Right? As opposed to following some meticulous rules of order of operations, and I got to negative 48. Whoa. So in conclusion, I know this is kind of a long video. I apologize, but that's because we were doing problems from the assignment. So you're welcome, right? I hope you can finish with the remaining time. But to cap it off, what does that mean? What does that mean? That means when I had this negative 3 in the box, negative 108 is the answer you get if you plug negative 3 into that function. What does this mean? That means that if you were to plug in the number 4 into this function, you would have gotten an answer of 4. You with me? Right? So synthetic division is a double whammy. It helps you divide, but it also helps you evaluate. Double whammy. Okay, with that, I really appreciate your attentiveness. I really appreciate that you gave it the good old college try, as they say. Um, I hope that you remain well behaved and try the assignment. Work with one another. I appreciate your time. Thank you for watching and have a terrific weekend. Be safe, stay well. All right, I'm done chit chatting. Peace out.